Hi and welcome to lesson 4 of our lessons relating to computer science. Hopefully in this lesson we're going to look at different types of memory. At the end of this lesson you'll come out with an understanding of mainly the difference between RAM and ROM. So let's have a look at what the specification says that you need to know with regards to memory. First thing, you need to be able to differentiate, that is, explain the difference between two types of memory the computer system uses. The first is RAM and the second is ROM. We need to know the purpose. So what is ROM used for in a computer system? What is RAM used for in a computer system? What's virtual memory? And what do we mean when we talk about flash memory? So let's just recap from one of our previous lessons. It's important to remember that the CPU fetches, decodes and executes instructions. That's what the CPU does. And it gets those instructions from main memory, from RAM. And inside of RAM, we'll find the instructions and the data that the CPU is currently dealing with. So when you go down to the Start menu in Windows and you load Microsoft Word, a copy of Microsoft Word is transferred from your computer's hard drive, from its secondary storage, into main memory, and then the CPU fetches each instruction that makes Microsoft Word in turn. Fetches it, decodes it, executes it. The data that you're creating as you're typing text into Microsoft Word is also stored inside of your computer's RAM. If you want to save that data, so you can come back to it at a later date, then you have to save it from RAM to your computer's hard drive, to its secondary storage. So it's important that we remember that particular idea. CPU fetches, decodes and executes instructions from main memory. The instructions that are in main memory will have come from the hard drive. So, what is main memory then? Well, the key thing we need to know about main memory is that it stores the programs and the data that you are currently using. So anything that you've loaded into your computer will be stored in main memory as you're using it. The data that you're typing into the program will be stored in main memory as you're using it. Obviously, if you switch your computer off or you have a power cut, then whatever you're working on in main memory is lost because main memory is volatile. You switch the computer off and whatever is in main memory will disappear. That's why at the end of every lesson your teacher normally reminds you to save your work. You save it to your secondary storage, to your hard drive, because your RAM is volatile. Other key characteristic of RAM is this idea that you can change the contents of RAM. So as you're typing text into your Word document, you're adding to the data that's in RAM. You're changing the contents of RAM. When you go down to the Start menu and you load another program, you're changing the contents of RAM. So it's important to know that the contents of RAM can be changed. And then typically, most computers these days will come with about 4 gigabytes of RAM. Typically, we're moving closer to 8 gigabytes being the standard. But the more RAM you have, the smoother your computer will be at running more programs at once. And we'll look at that in a little more detail later on. ROM then. ROM has a different function within the computer system. ROM stores the boot program needed to load up the computer. Sometimes this is called the BIOS, the basic input-output system. Without that boot program stored in ROM, the computer wouldn't know what to do when you first switched it on. So it's important that that ROM is there to store that boot program that tells the computer how to start. And because we can store the boot program in there, this means that ROM is what we call non-volatile. So ROM can keep its contents even when the computer is switched off. But ROM stands for read-only memory. And the clue is in the word read-only. We can only read what is in ROM, we can't change it. So unlike RAM, we can't modify ROM. You can't add new data to ROM. you can't change the data that is in ROM. Once it's in ROM, it's there, it's fixed, it's permanent. And typically most computers will have perhaps a few hundred K of RAM, depending upon what that computer actually is. So, we've touched on this before, but let's have a look at the impact that the amount of memory, the amount of RAM that we have in a computer system could have. So looking at two computers, two laptops here. Both laptops have the same CPU. They've both got an Intel Core i3 CPU, same CPU number, so we can assume the CPU is running at the same clock speed. But this computer here has 4 gigabytes of RAM. This computer here has 8 gigabytes of RAM. So although the CPUs are the same, the amount of RAM that each computer has is different. And therefore we would expect this computer, the more expensive one, to actually run particularly multiple programs at the same time more smoothly. So the more programs that you have got open at the same time, the quicker this cheaper machine will slow down. You'll start to see it getting sluggish. Also, if you're using fairly intensive programs, I'm thinking video editing programs, complex audio editing programs, the more memory, the more RAM you have, typically the smoother, the better that system will run. So the amount of RAM you have can have an impact on the performance of the overall system. So, multitasking. This has a big influence on how smooth your system is going to run, depending upon how much memory you have. The more memory, the more RAM you have, the better your system will be at multitasking, the smoother it'll be able to keep those multiple programs running at the same time. So a computer system that multitasks is one that's able to run more than one program at the same time. And we do this almost all the time on today's modern computers. You'll be using your word processor at the same time that you've got your web browser loaded in the background, streaming a music track from YouTube. You're multitasking. You've got a spreadsheet program open. You've created a graph. You're copying and pasting that graph from the spreadsheet program into a presentation you're creating. You're multitasking. You've got two programs running at the same time. And the more memory that you have, the more RAM you have, the smoother it will be at keeping those multiple programs running. And in a moment, we're going to look at why that's the case. So, one of the key factors that affects your computer's ability to multitask and the smoothness with which it will multitask is whether or not it needs to make use of virtual memory. And more specifically, how much virtual memory it needs to use. Now, cast your minds back. We've said that most computers have a limited amount of RAM, say 4 gigabytes. About 1 gigabyte of that is going to be taken by just the operating system, just Windows. Before you load any other program, you've got Microsoft Windows loaded, it's taking up around about a gigabyte of memory. That leaves you with only 3 gigabytes left. Some of that memory is going to be taken by your antivirus software that's running in the background, keeping your system safe and secure from viruses. You've then got your programs that you're going to be loading. Each of those will take additional memory from your system. So what happens is most modern operating systems will start to use some of the hard drive to make up for lack of physical RAM. And some of the programs that you're currently not interacting with but have got loaded will be copied together with their data to the hard drive, so that the system can focus on keeping active the program that you are currently interacting with. Obviously what that means is if all of a sudden you decide to change back to one of those programs that you minimized, the system has to go back to the hard drive, reload that program and its data into RAM, while freeing space in RAM by copying another program and its data back to the hard drive to keep these multiple programs running at the same time. And that's virtual memory, where we're using some of the hard drive space, some of our secondary storage, to make up for lack of actual physical RAM. And it means that you can keep multitasking, but the consequence of using more virtual memory will be that your system will slow down, because accessing a hard drive is slower than accessing RAM. And this is why, if you're finding that your system is starting to slow down, one of the most effective and cheapest upgrades that you can make is to actually add more RAM to your computer. That way it needs to use less virtual memory, and therefore it will spend less time accessing the hard drive. Another type of memory that we need to consider is something that we call flash memory. This is another word for solid state memory. And basically, flash memory combines the benefits of RAM with the benefits of ROM. You can modify the contents of flash memory. So you can change the data on your flash memory stick. You can delete files. You can add new files. You can modify the files on there. But unlike RAM, when you switch the computer off or unplug the memory pen, the data will still be there. Flash memory keeps its data even when the computer is switched off, or even when you unplug it from the computer and it has no power. And we'll typically find flash memory in things like memory pens, USB memory pens. Don't call them USBs. It's a USB memory pen. Memory cards that we might put into a digital camera, or memory cards that you might put into a smartphone or a tablet to increase the amount of storage. And one of the big advantages of this type of memory, of flash memory and solid state memory, is that it has no moving parts. Therefore, it's suitable for portable devices like smartphones, like tablets. It's also physically smaller. The data in flash memory is stored inside of tiny chips. Those chips are wafer thin, which means that you're able to create mobile phones that are really thin and really light. And the final advantage that we have of flash memory is that it's very quick to access, particularly compared to a normal hard drive. So, just to recap, these are the key terms that you need to be able to define. We've got RAM, or random access memory. It stores the programs and the data you are currently using. And it's volatile, meaning that it will lose its contents when you switch the computer off. ROM, read-only memory. That stores the boot program needed to start the computer when you first switch it on. ROM is non-volatile. It keeps its contents even when you switch the computer off. But its contents can't be changed. Virtual memory. This is where we use the hard disk space to make up for lack of actual physical RAM. And by using virtual memory, we're able to multitask more programs at the same time. Because even though we might have 4 gigabytes of memory, we can make it look like we have more by using some of the hard drive to act as virtual memory. Although that will slow the system down, because accessing the hard drive is slower than accessing RAM. And then we've got flash memory, which is a type of solid state storage. It has no moving parts. It combines the benefit of RAM with ROM. We can modify what's in flash memory, and flash memory will keep its contents even when the power is switched off. So, just another bit of trivia. You ever wondered why, when you've got lots of programs running at the same time, and you've minimized some of them down to the taskbar at the bottom of the screen, and you suddenly decide you want to switch back to the internet? So you click on the internet icon on the taskbar, loads it up, and all of a sudden everything freezes. You're waiting as the hard drive light flashes, as the screen slowly redraws itself. That's because you're running out of memory, and your computer's having to use virtual memory to make up for that lack of physical RAM. This we often call hard drive thrashing, where the computer is quickly switching data to and from memory in the hard drive to try and manage the lack of RAM that you have. But the problem is, it spends most of its time trying to copy the data to and from the hard drive rather than actually run the program that you want it to. And as we said before, the best way to avoid this is to add more memory, more RAM to your system, and therefore it's using less virtual memory. That's the end of this lesson. Hopefully I'll see you next lesson. Thanks for listening.